Hey, Michael here. I'm so glad you stopped by to check out this video. I want to tell you something about your Python program that is going to surprise you. I can almost guarantee it. It has the wrong memory settings. It has the wrong garbage collection settings. First of all, did you know that Python has two different types of garbage collections? It has reference counting, which is the primary way that memory is collected. As soon as the variables are done pointing at an object, it goes away, boom, just like that. Deterministically, immediately, that's how most of Python works. But you can create these cycles, and cycles will never get detected using reference counting. And so for that, we have a backup garbage collector that does mark and sweep and looks for those cycles and then cleans them up. That mark and sweep garbage collector runs rarely, but your program pays a high price for it, as we're going to see in this video. Let's dive in. So first of all, can we even control the garbage collector in Python? And second, will it really make any difference? And will that difference be something we want? Maybe the difference will be, hey, you are leaking a ton of memory and this is a great big problem. Or maybe not. In fact, I'll give you a hint, keep you watching. It's not going to be a problem and it will be faster. It's surprisingly awesome. So let me just show you, I wrote a little code for you to explore this idea. And the fundamental thing at play here is for Python's garbage collector, we have this garbage collection module, GC. It has a method called setThreshold. And so the way Python's garbage collection works is it says we're going to have a generation 0, generation 1, and generation 2 set of objects we're paying attention to. Gen 0 are the ones that have never been checked out. Gen 1, they've been checked once. And beyond that, the entire memory space is in Gen 2, which is a whole lot more than the others. And the other thing is what triggers a garbage collection. And this is the important thing. A garbage collection is triggered when the number of allocations of objects that could create cycles. So that is classes, dictionaries, lists, tuples, things that can contain other objects and pointers. There's a very limited set of those, but they show up all the time, as we'll see. When there's number of those get created is greater than, at the time, by default, 700 compared to the number of them that have been cleaned up. So if we're making a bunch of lists and so on, the lists will come into existence, they'll go away. But if the number that come into existence exceeds some threshold, 700 by default, more than the ones that have been cleaned up, boom, garbage collection happens. First to Gen 0, then some of the times those are upgraded to Gen 1, and then some of the times those are upgraded to Gen 2, the really expensive ones. So you got to remember, what we're working with here is not most of the objects in Python, but the container-like objects, lists, sets, classes, dictionaries, etc. With that in mind, what we're going to do is we're going to have a class, one of the ones that matches this category that can interact with garbage collection called dbitem. Imagine I'm doing a query from a database. It's going to have two things. It's going to have a floating point number and a list of dictionaries itself for each item. This might be a foreign key constraint or like a foreign key relationship that you do a join on in SQL Alchemy. And then we're going to do a query. In this case, we're not actually using SQL Alchemy. We're just creating them in memory to keep it simple. And we're going to create some number to simulate how many results we get. And for that, we're going to say we'll have 20 related items for each item, and we're going to put it into a list and return them. It's important that we keep them around because if they get cleaned up, remember that imbalance will not get triggered. But imagine I'm doing a super simple database query, episodes.all or objects.findAll order by, most recently released. That easily could be over 700. And you're going to have that triggered before you even get the results back. Like not every single database query should run a garbage collection just because you ran it, right? That's not great. All right, so we're going to simulate this. And then up here at the top, what we're going to do is we're going to capture the amount of memory used at the beginning and at the end using process util. And then we're going to go, say, for 100 times, we're going to go create 1,000 records of those things. That's quite a bit, but there are certainly places where we're working with a lot of data. And we're going to hang on to those in a list so they don't go away. Now let's just run it and see what happens. And we also haven't figured out how to change the GC yet. So I'm going to say no. When this runs, in the beginning, we're using 15.7 megs of memory before we did anything. And then we're using 175 megs. Afterwards, notice this number, 160 megs, was increased before the program was done and we let go of these items and so on. So fine. And this other number is really important, 370 milliseconds. So I'll run it a bunch of times. I'll say no because we're not really modifying it. So look, 400 milliseconds, 407, 300, but this number right here is stable. So it's around 350, 400 milliseconds to do this work, to create 1,000 database records 100 times. Okay, well, that's what it takes, I guess. Can we do any better? Well, let's go and work with this change the GC thing. You'll be super surprised. So we can use the GC module, which I've already imported at the top, and we can call this function get threshold. And what this is going to return is the allocations, GC0 and G1. And I'll just print out these. So these are the numbers I was talking about here. And I'll just say yes, so we see them. Notice every 700 allocations that creates that imbalance on collection types will trigger a GC. GC1 will run for every 10 generation zeros, and GC2 will run for every 10 collections of Gen 1. Maybe this should be named 1 and 2 to maybe make it more clear, like what it's really measuring. All right, well, there's a get threshold, but there's also a set threshold. And let's go and put it back the way it comes here, allocs G1, G2. But instead of allocations, let's put some number way over 700, 50,000, 100,000. We're willing to have a bunch of objects come back. Remember, if I do a database query and it returns let's say 10,000 records, 7,000 records, keep it simple, at minimum, that one database query is going to run 10 garbage collections before I even get the records back. How could they possibly be garbage? I haven't even finished creating them yet. That's insane. So this number, you want to think about what makes sense there. But for me, 50,000 or 100,000 is a real good number. And then we could also bump this out. I'm going to say for instead of every 10 going from 0 to 1 collections, I want to go 50. And maybe we could push that out a little bit farther too. Okay. Will that make any difference? I don't know. Remember, numbers, 160, 379 to 450 is what we were seeing. Let's try again. Yeah, let's go and do it. Wow. Two massive things to notice. Memory unchanged. We didn't lose or waste any memory. And a much more complex app. At worst, it would get cleaned up later down the line. So as long as you're not running out of memory, it should be fine. But look at this. More than double the speed. More than double. That is insane. That's fully insane. Let's run it again. Now, that's no fluke. Look at that. Even faster. 140, 130, 127 was that one. And every time, the exact same amount of memory. Literally. Do that at the start of your program, and for the rest of the life of your process, you will be reaping the benefits of this. You might say, well, Michael, this is an extreme little example. When will this ever matter for me? We made this change over at TalkPython training on our website. For example, if you go training.talkpython.fm/sitemap.xml, that page has to pull 4,000 items out of the database. I believe before we started tweaking this, we were doing 77 garbage collections to render a single page, the sitemap, on our site. That's ridiculous. We basically have exactly this code over there, and now it still runs 1 or 2, but it's way less bad. But don't take my word for it. Let's ask the garbage collector. We can go over, we can set this debug mode here, and let's run it. Watch this. I'm going to say, do not make any changes. Watch what happens. Collection. It's going. Oh my, what? I'm just trying to I'm not even done. I'm just trying to build this list here. I'm literally calling that function. Look what happened. 12 seconds. Oh my goodness. Collecting, done. 0 unreachable, 0 uncollectible. Probably 0 collected. Look at that. Collecting Gen 2, Just nuts, people. This is nuts. So, I mean, look at this scroll bar. You saw it go by. It's epic. let's run the exact same code with still the reporting on, but I'm going to just modify the garbage collection on line 20. Go. Done. It still did a lot of garbage collections, right? Like that's way more than you would have probably expected there. But yeah, still, I mean, that's still a lot. We could push this up higher and say, we should be able to run this code without much of GC going on, honestly. There we go. Put that at 100,000. 12 seconds, 0.3 seconds. Obviously, so much of that is the GC analytics. I'm going to turn that off. One other thing that we might want to do right before we run this is we could say gc.collect generation 2 and then gc.freeze. What that will do is this will force everything that's already in process. There's a bunch of startup in Python. It'll say, clean it up as much as you can. And then everything that already exists before my code starts running, that is no longer subject to garbage collection. Let's just assume it's going to be around for the life of this code. Run it now. Let's see what we get. Oh, perfect. Perfect. So we're kind of paying for this extra GC here. So there's a little bit more than normal, but if we run it again and we say, no, don't modify it. Look at that. 360 versus 150. Over 50% faster running this code. And so over on TalkPython, we saw maybe a 20% increase in our code, our website performance there. 20% is no joke. And running over a really long time, like days as the server's been running, since the last time we did a deploy or anything, the memory is, it went from like using 480 megs to 481, right? It didn't like blow up the memory or do anything crazy. And that's a full-on website doing ORM things and all, like lots of real stuff there. So this is amazing. I think this allox is way too low. If I can't do a simple database query without triggering many, many garbage collections, not what I'm showing on the screen, but like what we measured in production, it's too low. I don't know. To me, it's too low. So you can leave it. I wouldn't say every program should go mess with it, but if you have a data-heavy app, if you have something that has a lot of performance, it creates a lot of dictionaries and classes. Remember, every class has an associated dictionary unless it has slots. You probably want to think about doing something like this. If you want to find this code, I'll put a link in the description below, so be sure and check it out. You can play with it yourself. You'll need to install 2 libraries, psutil and Colorama, to support the reporting here. But other than that, it's just straight Python 3.10 for the moment. Well, how about that? We can make the garbage collector run less often. It runs much, much faster under certain circumstances. And we don't use any more memory. Crazy, right? If you're working on some insane algorithm that has a bunch of cycles, well, sure, leave the garbage collector set where it is. If you're building standard data-driven applications that pull a whole bunch of objects out of a database with an ORM or an ODM or one of those types of frameworks, you really want to think about what the right settings for your garbage collector are. Luckily, it's literally 1 or 2 lines of code and you're good to go. All right, well, I sure hope you learned a lot and enjoyed this video. Thank you so much for watching and spending some time with me. I really appreciate it. Please give it a like, subscribe to the channel if you want to get more like this. Also, we have an entire course over at TalkPython Training, a 4-hour course diving deep into this, understanding Python's memory at a really, really deep level. I think there's not just a bunch of interesting concepts, but there's actionable things like this and many others in that course. So I'll put a link in the show notes to my course as well. See ya.